it's a key feature of inductive and deductive reasoning.
What?
No, you can't. You need it to graduate.
No.
Can I take it in summer school?
I got no.
It's much worse in summer school.
Had some.
So,
Am I gonna finish it though?
today we're talking about reasoning skills. Reasoning skills is the logic that you use to back up arguments. Generally speaking, when we go through and we say things that we believe are true, unless they are facts, they often start off as what is known as a conjecture. It's an unproven statement based on observations and working with patterns. Making conjectures based off of patterns is called inductive reasoning. It's about what you intake to come up with conclusions about things. And again, this really focuses on this idea of working with patterns. So when we work with a pattern, if we describe what the pattern is, we're making a conjecture about what that pattern is. And then we can use that conjecture to come up with more items within the list. So one of the things you're going to see today is you're going to see some patterns, and it's going to ask, well, what is the pattern? If you see the letters S, R, Q, P, what's happening here? Alphabet, but that's not perfectly the alphabet, right? Alphabet goes A, B, C, D, E, F, G, etc. And you knew that. I know you know that. My 18-month-old knows that. So I know you guys do. That's not the regular alphabet, but you are right. It's coming from the alphabet. Get more specific. What was that? Backwards. S-R-Q-P. Is that alphabet backwards? Technically starting at S. Do we agree? Do I need to write out the whole alphabet for us to see this? At least the middle part. L, M, N, O, P, Q, R, S, T. Is it doing that? Starting at S? Yeah, alphabet backwards, starting at S. Now, if that is the case, can we come up with the next two terms in the list? In other words, the next two things. What would come after P?
O.
What would come after O?
N.
Ta-da. We have answered the question in both parts. Next problem goes 1, 2, 4, 8, 16, 32, etc. Timesing by what number? 2. Now, you don't have to write the second part, but generally, it's not a bad idea to tell where to start. That way, someone can get an idea of what the entire list is. It's multiplying by 2, and it started at the number 1. Okay. What are the next two terms in the list? Grab a calculator if you need one. 64 comes next. 64. Multiply by 2 again. What do we get? 128. Next pattern's visual. what's happening.
Or
No.
no,
Looks like they're going to sleep.
no, it'd be plus. You start with 1, and you can plus 2, which gives you 3, and then you plus 3, which gives you 6. So
So you're
it's just,
multiplying by 3.
no.
You're
It's
adding
3
3.
times 3 is.
You're adding 3.
Hey, yo. Sometimes you need to think a little less mathy, a little more picture-y. What's happening to the picture? Stop thinking about numbers.
They're telling a pyramid.
They're creating a pyramid. What's the next pyramid gonna look like?
It's gonna have
1,
1, 2,
followed by 2, followed by 3, followed by 4.
So pretty much it's just adding the numbers up. So it's just 1 plus 1. Then
Could I just describe it as adding a row to the pyramid? I don't know why I put a comma there. I've got the next term. I need one more term. I need one more pyramid. Starts with 1, then it's got 2, then it's got 3, then it's got 4, and then the last row that I'm adding now has 5. Inductive reasoning is a form of reasoning that's great to be able to use. The problem is that inductive reasoning is not perfect, because as you go through things, you can follow the pattern, but do patterns always hold true? Let's say you wake up in the morning, you decide to eat cereal for breakfast for a week straight. Does that mean the only thing you ever eat for breakfast is cereal? No. So inductive reasoning, it's great to figure out patterns, but it's not perfect. And that's where we like to work with other forms of reasoning known as deductive reasoning. Deductive reasoning uses facts and definitions and laws of logic. Laws of logic are kind of ways of thinking that are guaranteed to be true. There's 2 common laws of logic that we use, and we start talking about them on the next page. The law of detachment and the law of syllogism. The law of detachment says this: starts with that, I should say. There's more to it. Now that is notation that we talked about before break. If P, then Q, where P and Q are placeholders for statements. The law of detachment starts off with an if-then statement, a conditional statement, and then it also follows up with P. Anything in this structure is the actual law of detachment. Now, P and Q are just placeholders for sentences. And you technically could use any letters for those placeholders. So it could be if A, then B. The key thing is that after that if-then statement, the second statement is the hypothesis of the conditional statement. It has to match that first piece. If you have that, the law of detachment says you can do this. You can conclude. In other words, you can say that this following thing is true, and the thing you can say is true is Q. Is that conclusion piece of your if-then statement. Law of syllogism is a little more complex. It has two if-then statements. In its two if-then statements, the key thing when you have this, because it goes if P then Q, if Q then R, the key thing is this right here, and the fact that those match. You have two if-then statements, which you have a matching, one of which is a hypothesis, one of which is a conclusion. Now again, it could be any letters. I could have done if A, then B, if B, then C. Those match, we're fine. I even can rearrange them. If X, then Y. If W, then X. As long as I have one conclusion and one hypothesis matching, that is law of syllogism, and I am allowed to conclude that the unmatched hypothesis will lead to the unmatched conclusion. For this one, it would lead to if A, then C, and for this one, it would lead to if W, then Y. Now, there's probably many of you that are like, and that's okay. Let's get to the nitty-gritty of how we use this. It makes more sense when we get actual examples. So, you're going to see problems that look like this. Use deductive reasoning to answer the following. State the logical law you are using, state the conclusion that can be made, and if you can't do it, then just write no logical conclusion. So, first thing you're going to do is you're going to look for an if-then statement. In problem A, do you see an if-then statement? On the first if-then statement, if there's more than one. If there's only one, then it's just the if-then statement. The if part I'm going to call P. The then part I'm going to call Q. If two segments have the same length, then they are congruent. So P says two segments have the same length. Q is they are congruent. Now I'm going to look at the second sentence they have. Is that an if-then statement? No. If the second statement is an if-then statement, then you're checking law of syllogism because that's the one that has two if-thens. If it's only got one, then you're checking law of detachment. Note, I said you're checking. I didn't say it is, I said you're checking. The question is this. You know BC equals XY. Is that saying two segments have the same length? Is that saying two segments are congruent? Or is this saying something different completely? I know it's been a little bit. Are those segments if it's just the two letters without the bar above? Yes. If they are equal, do they have the same length? Yes, that's what that means. So that means this matches P. That means the setup I have says if P then Q, P. Is that setup either of these laws? Yeah, it's the law of detachment. By the way, this thing is a fancy bracket. You don't have to use the fancy bracket. That's just me writing out the fancy bracket. I like the fancy bracket. So, if two segments have the same length, then they are congruent. We know that BC equals XY. Now we can conclude. The conclusion for law of detachment is we can say that whatever Q is true. Q says they are congruent. What's the they? The segments. What are the name of the segments? I can say BC is congruent to XY. And if there's a shorthand for it like this, you can write out the shorthand. But that's what we are able to conclude. This is what today is looking for. Is determine if it's a law, which law is it, and if you're using a law, tell me what you know. Question B, if you're studying botany, then you are studying science. If you are studying science, then you are a scientist. First if-then statement, just mark it with P and Q. Second if-then statement. There's two if-then statements. If there's two if-then statements, it cannot be law of detachment. It would have to be law of syllogism. That's the one we're checking. For the second sentence, you try to see if anything matches. If you are studying science, does that match either the P or the Q? Okay, then I'm going to call this Q as well. You are a scientist. Does that match either the P or the Q? No, so I'm going to call it another letter. I like R. So my setup, the first sentence says if P then Q. My second sentence says if Q then R. Is that the law of syllogism? Yes, therefore we can make a conclusion. This one works. It essentially says, if you're studying botany, you are studying science. If you're studying science, you are a scientist. You can, therefore, come up with something that you know. According to the law of syllogism, you can conclude if P, then R. P is the unmatched hypothesis. R is the unmatched conclusion. If, and you don't have to write conclude, but this is what we're doing right here just for the sake of our notes. If which one is the hypothesis that doesn't match anything? Nope, that's the conclusion. That's the second part. You are studying botany. Then we want the unmatched conclusion. The conclusion's the then part. The then part that doesn't match is you are a scientist. Law of syllogism and law of detachment take some practice to get used to. So that's why there's so many examples of this. I just want to make sure we're solid on this, because the back's got examples too, I believe. Okay, if 90 degrees is less than the measure of angle R is less than 180 degrees, then angle R is obtuse. Angle R is an obtuse angle. I start with the if then. I call it what and what? PQ. I look at the second sentence. Does it have an if then? No, which means it's a single statement. I would be checking law of detachment. Does this match either P or Q? Matches Q. If P then Q, Q is what I have. Does that match the law of detachment? No. Law of detachment should go P, Q, P. Doesn't go Q. This is no law that we were given, which means we can't make a logical conclusion. It's this idea that just because angle R is an obtuse angle, according to this, we can't necessarily say it's between 90 and 180. Now, technically, that's the definition of obtuse, so that's a bad example, but we can't go backwards with this logic. Okay. If x is greater than 5, then x squared is greater than 25. If x squared is greater than 20, then x squared is greater than 25. I see two if-then statements. I'm thinking syllogism. I start with P and Q. Always start with P and Q on the first if-then. The second if-then should have two pieces. X squared is greater than 20. Does that match either of those? Which means I need to choose a different letter. Doesn't matter what letter.
R.
I like R. Does that one match either of them?
Q.
It's the same as Q. So it goes if P then Q, if R then Q. That's my setup. P, Q, R, Q. Is that one of my laws? The law that has two arrows in it is syllogism, but what I should have matching is diagonals. Not those. There's no law that fits this, which means no logical conclusion. We're going to finish up the examples on the back, but this is what we're focused in on today, is these laws. Okay, if you get an A in the math test, then you can go to the movies. My favorite actor is James Earl Jones. Okay, that's P, that's Q. My first if-then statement always goes if P, then Q. Is there an if-then statement here?
No.
No, which means I'm thinking law of detachment. Does this match P or Q?
No.
Which means I call it something else.
R.
If P, then Q, R.
That doesn't match anything.
Doesn't match a law, which means no logical conclusion. If it does not rain, then I walk to school. If I walk to school, then I wear my sneakers. First one's P, second one's Q. Here's an if-then, so I've got two letters to go into it. The if part. Match P, Q, or neither? Q. I will walk to school if I walk to school. Then I wear my sneakers. Match P, match Q, or neither? Neither, so I put an R. If P, then Q. If Q, then R. Does that fit my laws? Which law?
Second one.
Syllogism. If it matches the law, then it goes the hypothesis that doesn't have a match with the conclusion that doesn't have a match. These are the ones that are matching. Is P or R a hypothesis? It's the if part. P started with if, R started with then, so I need to start with the P. If it doesn't rain, then I will wear my sneakers. Law of syllogism essentially takes out information that wasn't necessary here. You can shorten down this idea of, well, if it doesn't rain, that means I'm going to wear my sneakers. Yeah, your reasoning might be because you're going to walk to school, but it's not what we needed. If a triangle has equal side lengths, then its interior angles measure 60. Triangle ABC has equal side lengths. Triangle, equal side lengths. Triangle has equal side lengths. It's not R, it's P. It's getting a little more specific. Sometimes it's not word for word. But sometimes they might say an item has this characteristic of P. But it's still P. If P, then Q, P. That is law of detachment. And for law of detachment, my conclusion is Q. I can say that Q is true. Q said each interior angle measures 60 degrees. Now I should relate it back specifically to this P. So each interior angle of triangle ABC measures 60. By the way, you could use angles for angle symbols if you want. Oops, I forgot. To relate it back of triangle ABC. Final one. Start with P and Q. Always start with P and Q. If x is greater than 1, then 3x is greater than 3. If 3 squared is greater than x, then 3x is greater than 1. I see another if-then statement, so I'm looking for 2 letters. That one doesn't match, so R. Does that one match? I already used Q. I used some other letter. It doesn't matter what letter. Pick a letter. I heard B. Dyslexic person nightmare. P, Q's, and B's. If P, then Q. If R, then B. Is that a law? No logical conclusion. For some of you, today may have felt very slow. For some of you, today may have felt like I was talking gibberish. It tends to go one way or another with the law of detachment and law of syllogism. If you are struggling, please ask. Doesn't mean there's anything wrong with your understanding. It's nothing wrong with you. It's just one of those things that you either get it immediately or you don't get it until someone talks to you individually. And typically it's about a 50-50 split in every class. That was section 2.2. Today is the 3rd. Our homework is due on Tuesday, which is the 7th. And it's a worksheet. What's happening Monday, by the way? Quiz. So should we wait until Tuesday to do this worksheet if it's on the quiz? No.